So this is a super interesting area of study, as far as like timing, like how should we time our protein intake. And as it turns out, so Don Layman, he runs a lab, a nutrition lab over at the University of Illinois. He's kind of one of the pioneers of protein research and protein intake and protein timing and quantity and all these things. He's put out a ton of research on this like anabolic window that you get from resistance training
Mm-hmm.
specifically. And early on, it seemed to be that, when you exercise, you're in a catabolic state while you exercise, meaning that your body's breaking down proteins and breaking down fuel. That makes sense, right? You're trying to exercise. You can't grow muscle like during exercise because you're in this catabolic state. Your cells have what's called AMPK. AMPK basically shuts off that mTOR, that mechanistic target of rapamycin. The guy who's just sitting there waiting, like, let's build. AMPK is like, hey, hold off, dude, chill out. That AMPK is activated when you exercise, so it kind of keeps mTOR at bay. And it's like, okay, we need that breakdown feel right now. Our muscles need this energy to go through whatever stress this is. It happens to be exercise in this instance. So mTOR is like, fine, all right, just let me know when I can build. and and so this process of being in a catabolic state while you're exercising actually shifts to be quite anabolic after exercising, especially resistance training. So resistance training, as you're breaking or as you're providing this stress to your muscle, it basically, after you're done exercising, stimulates that muscle to be like, whoa, that was tough. Let's build so that next time that happens, we're going to be a lot stronger and a lot more well equipped. So mTOR is like, yo, 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 build
I'm
more muscle
back,
fibers,
baby.
active myosin, get going. And then you have these muscle cells are what are called multinucleated cells. They have multiple nuclei. Most cells just have one nucleus within them that, well, I should say all cells other than muscle cells have one nucleus within them that tell the cells what to do. Muscle cells need so much freaking protein and they need to build so much that they have multiple nuclei just kind of sitting all around. And mTOR's like, yo, 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 satellite cells, that's what they're called. Start making more actin and myosin, grow, grow, grow. And you start to see bigger muscles and better capability to improve strength and such. So that anabolic window is very high immediately after exercise, but it's actually sustained for up to 12 to even 24 hours
Oh,
after.
okay, so the
Actually, there's
window
research
isn't as
suggesting
short.
36 hours
I
afterwards.
always thought it was 30 minutes.
So,
That's how like my protein bags are like 30 minutes after take this
That's
post
yeah.
workout
That's what I've heard is
every
like
single
you
day.
have 30 minutes to get your protein. I'm
Yeah.
like, I can't get home, cook dinner in
Yeah.
5 minutes,
Takes
and
me
eat
30 minutes to get
protein.
home.
So
so what's interesting though about the literature? So early studies suggested that we had this 2 hour anabolic window to
hmm
take advantage of. And that still seems to hold true in some aspects, but it turns out it depends on how trained you are. Now, if you're an untrained individual going through early phases of a resistance training protocol, you're going to be a lot more catabolic when you're exercising, and your anabolic window is actually likely going to be a little bit shorter. And so if you're getting into resistance training, you may want to take advantage of this high anabolic window after resistance training, which could be around 2 hours, but it's actually likely a lot more. And supplement after your workout. But I
does
mean,
that depend on how hard you train?
it does. It absolutely does.
Okay.
So if you're training to grow muscle and to grow strength, you're training at a high intensity, whether it be repetitions, weight sets, or what have you. If you're not training at a high intensity, you're not going to stimulate this anabolic window as much. And it turns out that that anabolic window is ramped up quite a bit uh, after resistance training for a couple hours. But um, if you're highly trained, that anabolic window is so much more constant, or it's prolonged because your body is habituated to this frequent exercise, frequent resistance training, plus frequent protein intake. If you are a highly trained individual, you're focused on your protein intake, you're focused on resistance training. Your body is getting that stimulus of anabolism constantly. And so protein timing isn't going to be as much of a big deal if you're highly trained. You just want to make sure you're getting enough protein throughout the day circulated through meals. So it's not as big of a deal. There was a pretty cool study that was just done a couple months ago. And what they did is they took a group of adults. So these were adult males, and they had them. First of all, I can't talk today. First of all, they divided them into a few different groups, but they screened them to see their activity level. So they didn't want sedentary individuals. They wanted someone who worked out at least 1 day per week, but somebody who didn't work out more than 3 days per week. So 1 to 3 days per week was their activity level. So, trained but not fully adapted probably. And they had them in different groups of no protein intake, 25 grams of protein intake, and 100 grams of protein intake after their workout. And they, when they just did one workout, it was a full body workout, and it was pretty high intensity. They did a warm up, they were on the bike, and then they did a lat pull down, leg press, leg extension, and a chest press at 80% of 1 rep max for 4 sets. And they ended up inducing failure on sets 2 to 4. And so that's a pretty difficult workout if you're going to failure on multiple sets. So you know that there's been protein damage that's been induced. And then they gave them the protein immediately after. And what they saw is that there's this increase in this anabolic state, or this ability of the muscle to go through protein synthesis as protein increases. And that anabolic window, they had them sit in this lab for 12 hours and just chilled. And they were checking their blood, checking their muscle, checking their blood every 30 minutes, checking their muscle samples. So they were basically like grabbing a sample of a lower body muscle every 4 hours for that 12 hours as they're just sitting there. So those participants are amazing. I want to give them a high five. And they were looking at how well did the muscle take up that protein and induce protein synthesis, and what happened for 12 hours. And they were still in this anabolic phase, even just chilling there afterwards. But what that gets at more is that protein intake is also inducing that anabolic state. So it's not, in this instance, it's not just the resistance training group. So the control participants had improved muscle protein synthesis and were in an anabolic window from the resistance training, but adding that protein did prolong it. And so if you are adding protein after your workout, you're prolonging that anabolic window. But again, and it's much longer than you would think. I mean, in this paper, they showed it was still elevated 12 hours post consumption. And yeah, so it's not quite the timing of protein after exercise specifically isn't so, set in stone here. It probably depends on your level of training.